Okay. Now let's look at this example. We combine the force analysis and the frictional force. A block with 10 kilogram mass is released and rests on the inclined plane with 36.9 degree angle. Find the acceleration at the moment of releasing. Okay, we just want to find the acceleration at the moment of releasing. A, if the coefficient of static friction mu s equals to 0.6. B, the coefficient of static friction mu s equals to 1. Okay, let's see if the coefficient is different. What difference does it make? Okay, similar to those analyses. Okay, the situation looks like this. This is the frictional surface, so you have frictional force. We are talking about the moment of the releasing, so it still stay at rest. So the frictional force is the static friction. Okay. After that point, of course, it may start to move, so it will be a different story. Any question here so far? Now, let's look at the key is to determine the static frictional force. But of course, we know that the static frictional force, you cannot simply calculate it as mu s multiplied by n, because that's the maximum possible static frictional force. To get the actual static frictional force, it's not that straightforward. You have to compare the external pulling force with the maximum possible static frictional force. So the first thing we have to calculate the external pulling force and the maximum static friction force. The maximum static frictional force should be, let's first do A. Okay, mu s multiplied by n. A mu s equals to what? 0.6. 0.6. Okay. Okay, so even calculate the static frictional force is not that straightforward. Okay, we have to go through the procedure from the beginning. So, okay, here there is a common mistake. Mu s, Fs equals to mu s multiplied by n equals to 0.6 multiplied by mu s multiplied by mg equals to 0.6 multiplied by, what's the mass? 10 multiplied by 9.8. Please note this is wrong. What's wrong here?
Decompose it. Full weight instead of the y component.
Okay, so what's wrong here is that in this calculation, I'm assuming normal force equals to mg. This may not be the case. Okay, look at here. The normal force is not in the same direction of W, so it wouldn't be exactly the same as mg. Okay, so go through the form procedure. So we should have do the decomposition. We can choose. Remember, we have some situation before. We don't have frictional force, but this is positive x. This is positive y. So we have to decompose W to get Wx. Wy, right? This is Wx, this is Wy. This is 36.9 degree. So this is also 36.9 degree. Okay, so that means Wx equals to W or mg multiplied by sine or cosine? Okay. Sine, okay? Wy equals to mg multiplied by cosine 36.9 So if I use 10 for G, okay, for simplicity. So 10 multiplied by 10 multiplied by sine 36.9 is 0.6. So it's 60. So this will be 10 multiplied by 10 multiplied by 0.8, so it's 80 Newton. So Wx equals to 60, Wy equals to 80. Question?
What's the case? Why W will be negative?
Okay, yes, it will be negative, but here I'm just calculating the magnitude. Later, I'm going to put the negative side in the equation. Of course, it should be negative. Okay. So now, if I'm trying to write down the Newton's second law, question?
Sorry. Going back to the Wx, why does it say 10 times 10 times 4?
Mass is 10, and G is 9.8. I use 10, okay, for simplicity. So now, the next step is to write down the Newton's second law. Along x direction, I should have Wx subtract Fx. That's the next form, right? Equals to ma. So actually, I'm going to calculate acceleration from this equation. Okay, but here I still need to determine the static frictional force. Along y direction, the importance of the y direction is you should get n minus wy equals to may. Precisely, here is max, this is may. Okay, that's a true equation. Any question here? For the Newton's second law, how can you write down them? I'm just write down the equation F equals to ma in a detailed form. And then you can simplify. This one is Wx, what's that? 60. Okay. Minus, so let me just keep it here. So first, let's identify Ax and Ay. We know that, okay, we did the analysis before. In this case, Ay has to be 0, right? So Ax has to be A. So you get Wx minus Fs equals to ma, and n minus Wy equals to 0. So you can see the second equation actually tells you the normal force N is not mg, it's Wy, it's not W, it's Wy. So equals to 80. So normal force is not 100, it's just 80. Okay? So then the maximum static frictional force, according to this, should be mu s n, so equals to 0.6 multiplied by 80. Okay, 0.6 multiplied by 80. So 48 Newton. Okay. Now, we have to compare the maximum static frictional force with external pulling force. In this case, which one is the external pulling force? Which one force is the force has to be try to overcome
Wx.
Wx. And we know Wx equals to 60 newtons. So if we compare the two, which one is larger? So Wx is greater than Fs max. So actual static frictional force should be the same as which?
Fs max.
Fs max. Okay. Equals to 48 Newton. So now we can calculate acceleration from this equation. Then we get 60 minus 48 equals to 10 times 8. The acceleration will be 1.2. Right? Any question here? Please note that here, how the key, okay, other things I can straightforward. The key is you need to determine the static frictional force by comparing Wx and Fs max. Okay. Now let's look at B. If mu s equals to 1.0, all this analysis, Newton's second law stuff wouldn't change. So you still have Wx equals to 60 Newton, Wy equals to 80 Newton. So you still have the two equations Ws minus Fs equals to Ma, and N minus Wy equals to 0. So you still have N equals to Wy equals to 80 Newton. This will give you Fs max equals to mu Sn equals to 48 Newton. Oh, sorry, no, not 48. Mu S now then equals to 1, right? 1 multiplied by 80. So equals to 80 Newton. Please note that you have a different coefficient. So that increases the maximum static frictional force to 80 Newton compared with 48 there, okay? But in part B. So in this case, if we compare it with 60 Newton forward force Wx, which one is greater? So Wx smaller than Fs max. If Wx is smaller than Fx max, what is the static frictional force? 60 Newton. Okay. So if we put this into this equation, we should get 60 minus 60 equals to 10 times 8. So 8 equals to 0. Okay. So this situation corresponding to the external pulling force Wx is not large enough to overcome the maximum static frictional force. So it wouldn't make motion. Acceleration equals to 0. It will still be there. But in that case, the object will start to move. Okay? Any question here?